Hey everyone, welcome back for another deep dive. Today we're taking a look at AI that can watch and understand videos.
Really?
Almost like we do. We're talking about video LLMs.
Right.
And a big problem they have with really long video.
Oh, yeah.
Imagine all that footage, hours and hours. It's a lot for even a powerful computer to process.
It is.
But that's why this is exciting.
Absolutely.
Because there's a new architecture called Storm.
Okay.
And this is changing the game, and it's all laid out in this brand new research paper. Just came out March 7th, 2025.
Wow. Just came out.
Super fresh.
Yeah.
Called Token Efficient Long Video Understanding for Multimodal LLMs.
Catchy title.
Yeah, I know, right? But really, this isn't just for tech people. This is about AI that can understand the world better.
Yeah.
With applications we haven't even thought of yet. Now, I know this paper gets pretty technical in places.
It does.
But luckily, we have an expert here to help us break it down.
Happy to help.
So maybe let's start with the core problem. Most of these video LLMs, how do they approach video? What's the issue?
Yeah, so the problem is most of them are kind of stuck analyzing each frame of the video as if it's a separate picture.
Oh, so like a flip book.
Yeah, exactly. Like a flip book instead of an actual movie. So they miss the whole flow of the act.
They miss the story.
They miss the story. Yeah, exactly. It's a lot of work for the AI and it's not very efficient.
Yeah. Like if you were trying to understand, I don't know, the plot of Star Wars, but you were only looking at random stills.
Yeah.
You'd never get it.
You would never get, you'd have no idea what's going on.
Yeah.
But Storm tackles this by adding something called a temporal encoder. So it's almost like giving the AI a sense of time.
Wow.
It can see how things are moving, how the actions are evolving over lots of frames, not just one by one.
Now this temporal encoder.
Yeah.
It uses something called a Mamba Space Model.
Yes.
And I'm curious, like, what does that even mean?
Right. So Mamba, it's known for being really good at compressing information, but keeping the important stuff.
Oh, okay.
So it's like, imagine you have a huge long report and you just want the key. You still get the main idea, but it's much shorter.
So the AI is not getting bogged down in all the details.
Yeah, exactly.
Just focusing on the key events.
Exactly.
That's pretty cool. Now, all of this sounds great in theory, but does it actually work? Does this Storm thing outperform other models?
It does, yeah. The paper actually shows it beating existing models on a number of benchmarks, including some really tough ones that big tech companies use, like MLVU and LongVideoBench.
So this isn't just some theory, it's actually proving itself.
It's proving itself, yeah, and it gets even better because it's not just smarter, it's also way more efficient. It can process the same amount of video, but it uses much less power, up to 8 times less. And it's also much faster.
That's impressive. So we're talking about an AI that can watch and understand long videos, use less energy and do it much quicker. That's incredible.
It is.
I mean, how much faster are we talking about?
The paper says it reduces something called decoding latency 2.4 to 2.9 times.
Decoding latency. That sounds a little intimidating.
It does sound technical.
Yeah. Can you break that down for us? What is that?
Sure. Decoding latency is basically how long it takes for the AI to actually process and understand what's happening in the video.
Okay.
So lower latency just means it can understand things much faster.
Got it. So Storm is understanding things better. It's doing it faster.
Yeah.
And using less power. That's pretty amazing.
It's pretty amazing. And it's particularly good at those super long videos we were talking about. It can even process up to 128 frames while still using the same computing power as older models on just 32 frames.
That is a huge difference. So it's like Storm is watching a whole movie while the other AI is still stuck on the opening scene.
Yeah, that's a great way to put it. And the longer the videos get, the more Storm pulls ahead. The paper compares it to a more basic model called Vila. And you can really see as the videos get longer, Vila starts to struggle, but Storm just learning and improving.
So Storm has this stamina.
It does.
It doesn't get tired or
It doesn't.
Even when there's tons of information.
Yeah, and a big part of that stamina comes from its ability to compress information really efficiently.
Okay.
Which the paper dives into in detail. They talk about techniques like temporal pooling and spatial pooling.
Intriguing. Let's break those down. What are temporal pooling and spatial pooling, and how do they help Storm be so efficient?
Okay, so imagine you're watching a movie, and instead of taking in every little detail of every frame, you just focus on the key moments, the turning points in the plot.
So it's like making a highlight reel.
Yeah, exactly.
Right. So Storm takes these groups of frames, frames next to each other that are visually similar,
Right.
And it kind of compresses them. Okay.
Averages the data into just a single representation.
Yeah.
So it's still capturing the essence, but it's doing it in a way more efficient way.
But it's kind of like, those scenes in a movie where not a whole lot is happening.
Right. You could condense that down to a few seconds and still get the story.
Yeah.
And this doesn't just save computing power.
Yeah.
It can actually improve accuracy cases because by filtering out all that unnecessary visual noise,
Right.
Storm can really focus on the core elements.
That's interesting. You'd think more detail would always be better, but sometimes it's just distracting.
It's like trying to listen to a podcast in a really noisy room.
Yeah.
Sometimes filtering out that background noise helps you understand what's being said so much better.
Great analogy. Okay, so temporal pooling is all about streamlining over time.
Right.
What about spatial pooling? What's happening within each frame?
So think about like adjusting the resolution of a photo.
Okay.
You can lower the resolution, you can still see what's going on,
Yeah.
even though some of the finer details are lost. That's kind of what spatial pooling does. It simplifies each frame by reducing the amount of pixel data, but it keeps the overall structure and content.
It's like, looking at a photo and focusing on the main subject, not worrying about every little detail in the background.
Exactly, exactly. And by combining those two,
Yeah.
temporal pooling for condensing the video over time and spatial pooling for simplifying each frame, that's how Storm gets so efficient without sacrificing comprehension.
So it's kind of like Storm is watching a movie with this laser focus cutting through the clutter to get to the good stuff.
Yeah, that's a great way to put it.
And, we were talking about earlier about how Storm can compress information even during testing after it's already been trained.
Yeah.
They call that temporal sampling.
Yes.
It adds even another layer of efficiency.
It does.
So it's out in the real world analyzing new videos, and it can still adjust
Right.
its level of detail to optimize its performance.
It's like having an AI that can adapt to different situations.
Yeah.
And choose the most efficient way to process information.
So it's constantly learning
It's constantly learning, yeah.
and evolving its approach.
Exactly.
That's incredible.
Yeah, so many possibilities. Think about analyzing security footage. Storm could go through hours and hours and pinpoint the exact moments where something important happens.
Right, like someone entering a restricted area.
Exactly, or an object being moved. It would save security personnel so much time.
Tons of time.
Yeah, or imagine using Storm to analyze sports replays.
Oh, yeah.
It could create highlight reels automatically, identify key plays, and even provide insights into player performance.
That would change the way we watch sports.
It would. It really would. And it goes beyond security in sports. You could use this for medical imaging, traffic patterns, weather data, you name it.
Like an AI that could help us understand all this video data that's out there.
That's right.
Unlock insights that were hidden before.
Exactly. And it's all very exciting, but it's important to remember Storm is still very new.
Right.
There are some challenges, limitations that the paper talks about as well.
That makes sense. Every new technology has its hurdles. What are some of the challenges facing Storm?
Well, one challenge is finding the right balance between compressing the data and keeping enough detail.
Right.
Because if you oversimplify things too much, you lose important information.
Like summarizing a whole book down to a single sentence.
Exactly. You get the main idea, but you miss all the nuance and the complexity.
Yeah.
And, Storm has done amazingly well on the benchmarks we've been talking about.
Yeah.
But it's important to remember those are just a small snapshot of the real world.
Right.
There's a chance it could struggle with more complex or unpredictable video content.
So, we need to be careful about overhyping. Its capabilities, it's a powerful tool,
It is?
but it's not magic.
Magic, yeah.
And as with any powerful tool,
Right.
we have to think about the ethic.
Absolutely.
We can't just blindly embrace new technology without considering the risks.
Exactly. That's a conversation we need to have as AI becomes more and more part of our lives.
Yeah.
But even with all that said,
Uh-huh.
Storm is a huge step forward.
Yeah.
In video understanding, it's a technology with so much potential.
Yeah.
It could really change a lot of things in our world.
It's an exciting look into the future of AI.
It is.
It might change all our lives. But, we haven't even touched on how Storm is actually trained.
Well, that's right.
That's a whole other fascinating aspect.
The training process is so important to understand how it gets to be so good at what it does.
Yeah.
It's actually a two-stage process.
Oh.
It really shows the brilliance of the researchers behind this project.
All right, let's hear it. I'm ready to delve into the training regimen of this video understanding superstar.
It is. So the training, it's broken down into two main stages.
Okay, so like basic training and then specialized training.
Yeah, that's a great way to put it. The first stage is called the alignment stage, and it focuses on getting Storm's sense of time, using that Mamba temporal encoder you were talking about.
So it's learning to understand how the actions flow in a video even before it knows what those actions are.
Exactly. And what's really interesting is they don't even use videos in this first stage.
Wait a minute, how can it learn about video if it's not seeing video?
That's the clever part. They train it on a massive data of image-text pairs. So remember, Mamba, it's not just good with time, it's also great at spatial scanning, within images.
So it's learning to see relationships between things in a still picture.
Yeah.
And then later that helps it understand relationships between frames.
Exactly, exactly. It's building this foundation
Wow.
for understanding how visual information connects over time.
Interesting. So it's like they're giving Storm a basic understanding of grammar before teaching it to read.
That's a great way to put it.
Yeah,
And
yeah.
then once it has that foundation, it moves on to the second stage called supervised fine-tuning, or SFT for short.
Okay, so now it finally gets to watch some videos.
Now it gets to watch some videos, and not just any videos. They use a diverse set that includes, text only, image text, and video text.
So it's learning to connect language and visuals from all sides.
Exactly. And during this SFT stage, they actually focus on training with videos that are 32 frames long.
Okay, why 32? Is there something special about that number?
It's kind of a sweet spot. In terms of efficiency and memory, remember that 8K token limit we talked about earlier?
Yeah.
So 32 frames with all those token compression techniques, it keeps them within that limit.
Okay.
So the model can actually process everything.
So they're finding that balance between giving it enough information to learn, but not overwhelming it.
Exactly, but they don't stop there. To fine-tune Storm for those really long videos,
Yeah.
they actually introduce an extra training stage using 128 frame videos.
Hold on, wouldn't that go over the limit?
That's where the token compression really shines.
Okay.
Because by using temporal pooling,
Right.
it can actually compress 128 frames down to like the equivalent of 32 frames.
Wow.
In terms of the token count,
That's impressive.
so they can train with those longer videos
Yeah.
without going over the limit.
It's like they're giving Storm this superpower to handle massive amounts of data.
It is, and the results, they speak for themselves.
Yeah.
Storm, it consistently outperforms all the models. It really shows you the power of that two-stage training and the token compression.
So, we've talked a lot about the technical details, but what does all this mean for like the average person? How will Storm change the way we watch and use videos?
Well, imagine a world where you can search through hours of video footage.
Yeah.
As easily as you search the web today, you could find that one moment
Oh, wow.
in your home security footage.
Right.
Or pinpoint the exact scene in a movie.
Yeah. No more scrubbing through endless hours trying to find that one clip.
That's right. Or imagine personalized educational videos.
Oh, okay.
That actually adapt to your learning style. They skip over the parts you already know.
Yeah.
And focus on areas where you need more help.
That would be amazing. That would change online learning forever.
It really would. The possibilities are just endless. Storm, it's a paradigm shift in how we understand videos. It's bringing us closer to an AI that can not only analyze videos, but actually comprehend them. Unlock insights that we just couldn't see before.
It's really an exciting look into the future of AI and what it could mean for all of us. It really makes you think.
It does.
Well, this has been a fascinating look at Storm.
It has.
Its capabilities, its potential impact, really groundbreaking stuff.
Absolutely a real deep dive.
As always, thanks for joining us on this intellectual adventure. Until next time, keep exploring, keep learning, and keep diving deep into the world of knowledge.